Ladies and gentlemen, welcome. Thank you for coming to this talk. It's called Roll Your Own Network Stack and Make It Spark Joy. Because you know what? You deserve nice things. Let's start with a philosophical question. Who am I? We kind of went through the intro already, but just very quickly, my name is Frank. This is what I look like on social media. So usually you might see this in like a circle. No verified logo though, so that's unfortunate. I'm from Montreal, Canada. I've been doing this like iOS stuff since like iOS 4, iOS 5. It's funny, the first talk during the keynote when we were talking about like Arc, it reminded me of like when I started between like iOS 4 and iOS 5 when Arc was being introduced and I understood nothing. Like half of the code online would like just not work because of all like manual retain release. That was fun stuff. But yeah, I miss green felt though. That's what I would like to see come back. And I'm at Frankisy on Twitter, so please follow me. I'm desperate for attention, so it'd be really great. It'd be really great if you follow me. I'll remind you at the end as well. All right, so let's talk about the talk. Today we're going to be refactoring some code together. Okay, so we'll be doing that. We'll be building like small abstractions as we need them. And I'll do my best to explain like the reasoning behind it as we go. And you'll see we might go a little bit slow. I don't want to say slow. Well, we're going to take our time, but in doing so, hopefully there won't be any like huge jumps in logic, and even like the newest among you to the iOS world will be able to follow. And of course, we'll make it spark joy. However, I just want to put like a little caveat up there. Like this talk is not a roller coaster. So that is to say, it will not be fun and exciting. I kid. What I mean is like sometimes you see these talks where you're building like these like big frameworks and you're kind of like set on rails and you need to go from like point A all the way to the end and you have to use the whole thing or else nothing works. That's not what this talk is about. This talk is more like a shopping spree. So I'm going to show you things. You take what you like. You can use it in your own code. Like I won't take it personally if you don't like it. But at any point, you can make like Cartman and go home. And but if I do my job well, you won't want to. All right. So let's start off with requests. Good place to start off with networking. In building this talk, I was like looking for inspiration. I was looking through some old projects I have worked on, and I found actually my very first iOS project was like a rideshare app in Objective-C. And this project, it was something special because it prominently featured my favorite design pattern. It's one that I knew very well starting out, and that's massive view controller. It was like an incredible display of massive view controllers. My view controllers were so massive. They had so much stuff. They had like conditional segue navigation. They had core data. And of course, like any good massive view controller, they had networking. So you can imagine it looks something like this, right? You're in view did load, and then it's like, boom. It's right there. It's like in your face. This is what we're going to be working on today. So I'm going to go through like this. The code might be a bit small, but it's not super important. We have URL components. We have URL. So we're building a URL out of URL components. We're using the Star Wars API today, simply because it's an API that doesn't need authentication. It's like one of the few. So we're using that. It adds like a query item, a header, and then it throws it out to URL session, and then things come back. You decode your data. You set it on the view controller. You don't handle errors. This is like typical massive view controller code. Like you've seen this before. And then when it comes to kind of like approaching this, I like to ask questions. So you ask questions to the code, and then the code replies back. So you can ask questions like, who the hell wrote this? Unfortunately, it's me, so that's kind of a bad question to ask. Then you can ask questions like, okay, what data here like doesn't make sense on its own? So say, for example, if we like highlight these parts here, take any one of these lines, say like a URL query item for the search parameter. Like this on its own doesn't make that much sense, right? It kind of needs like this larger context around it for it to be meaningful. So in asking questions like this, then we can kind of like suss out like, okay, where are the data types here? Like what are the things that we can pull out, put into a struct or a class, and then use to refactor this code. So I like to boil them, mash them, stick them in a struct. Here's a fetch people request. So I'm going to create a struct. It has a few variables to like essentially model what's going on. HTTP method is get. It has the URL that we had before. It has a variable for storing query items and also for the headers. It also has an initializer, right? And this initializer, you pass in a string, and that string gets added as like the search parameter. So essentially, that's the string you're searching for. If you want to find Darth Vader, you put Darth, and you get Darth Maul, and then you get Darth Vader. So we have this, and already, just seeing this, we're already in a better spot, right? Because now we're better communicating intent. We have a request. In order to initialize this request at all, you need to provide a string to search for. So that's already like better communicating what we want to do with this thing. So that's good. But in order to use it, we kind of need a bit of scaffolding around. So let's create an extension. We'll add a computed variable called full URL. This is the URL component stuff that we had in the view did load before. And then we add an extension to URL request. So here we're going to create a URL request out of this like kind of request template struct that we devised. And essentially, it's just taking stuff from the struct, sending it, and like setting it on URL request. Then once we have that URL request, we can pass it on to URL session, and then URL session can do its thing. So originally, our view did load looked like this. And now, oh, well, I put a transition there. OK, and now it looks like that. So hey, it's a bit smaller. Great. It's a bit smaller, and again, we're better communicating intent, so we're in a better place. Now, obviously, your app does more than one thing. This app too. So we create more requests. Here, there's one to fetch a person with an ID. Underneath, we can fetch a list of like different Star Wars starships. And now we're starting to see, okay, there's a bit of duplication here, and we're not going to recreate like these extensions and stuff for each of these types individually, right? Like that doesn't make too much sense. And so we're going to reach for the tool that all Swift developers love. Dave Abrams said it best. Start with a, yes, I heard it. Who said that? I actually can't see you all. But so whoever said it gets a prize. Come see me afterwards. So we extract this out into a protocol. So there we go. This protocol, I'll call it Requestable. Seems like a good name. And again, it has the variables that you would expect. All right, so now let's go ahead and move our extensions over. So these were extensions on our concrete class. We're just going to change it and move it over to Requestable. And hey, just like that, it works. Great. But now we need to make this spark joy. So this isn't quite spark joy just yet. Now that we have a protocol, we can start doing things like setting like sensible defaults. So for instance, we can say that, okay, most of my requests in my app are going to be like GET requests. So let's say that the HTTP method is GET. Let's say that most of my requests don't have any parameters, so we can leave that empty. I'm always, well, pretty much always going to be receiving JSON, so we'll set that, and generally my body will be nil. Once we have that, then we can start to like redefine the requests that we already have in terms of like these defaults. Then we end up getting something like this, which is very like minimalistic. It's It's very small, it's very tight, compact, but it packs a punch, especially since we have all this scaffolding around to make it work. So this, I find, is rather nice. And even you can go a bit further. You can make things a little more type safe. For HTTP methods, you could define them as an enum. For things like the keys of your headers, you can do something like this here. Create a struct expressible by string literal and have like constant strings on there to define that. So far, where are we at? Again, better cohesion, right? The things that belong together are together. It's better encapsulated. So from the point of view of our view controller, it has doesn't have an idea of like what URL it's calling or whatever. So that's nice and encapsulated in its own request. And we're better communicating intent. We simplify the call site, right? We're getting a bunch of code out of there. Kind of in the spirit of Swift, simple requests are easy to create. This is one of the things that I love about Swift, where like the easy case, or the simple case is easy, and the hard cases are possible. This is kind of what we're trying to do here. And of course, these requests are now easy to test. Like before, this wasn't testable at all, but now you can assert against either the request's full URL, or you can assert against the foundation URL request that gets created from these structs. So there you go. Part 1 done. Now let's talk about responses. So there's a huge omission here, right? Type-safe responses. I'm sure there are many of you who've jumped ahead and who think like, but Frank, it's like if you're defining a request, why not, stick the type of the response in there and then use that to, decode your data and have like this nice little package. Like, I get it. And like our big view-did-load method, that would correspond to like about all of this part here. So this is what we're going to try to fix. I have some thoughts about separating requests and responses. And I think this is important. So usually online, you're going to see this, right? Like people try and create abstractions over network requests, and they'll like bake in the type of the response directly into the request. But I think maybe that's a little heavy-handed, because first of all, not all requests decode to JSON. So I think it's you're like maybe getting a bit ahead of yourself, like if you're assuming that that's the case. Also, not all requests decode to the same type all the time. Like you could imagine that you fetch like this big like user blob of data, but in some cases you want to decode it to the whole user, but in other cases it might be more useful to decode only a smaller part of that response. So I kind of want that to be possible. And of course, I mean, some requests don't decode anything at all, right? Like you could be downloading data from a web server, and you want to save it to disk. Say you're like caching some JSON for later. That might be interesting to just, not decode anything and just take the data you get and plop it on disk. So, of course, I'm going to create a struct for that too. I'm going to call it fetch people resource. So it's going to wrap this request that we made for the fetch people request, and it's also going to have like this block where it decodes the data and then returns an array of person. Now again, we need to build a bit of like scaffolding around, and while this seems really intense, this is pretty much the most basic URL session code you can write. It takes the resource, it creates a URL request, and then with the data response and error that it receives, it either calls a completion with a failure or a success, depending on what you get. Also, it runs that decode block that we added to our struct in order to like extract the data from the response. Okay, now if we come back to view-did-load, now it starts to look like this. And I think this is starting to get like a lot nicer than what it was before. So again, we still have this request that we made. Now we create this resource type, right? And in there, when we receive the data, we do the decoding. And then we pass that along to URL session, create a data task, and then this second closure here, all it does is it interacts with the view controller. It doesn't care anymore about like what's going on the networking side of things. And of course, you have to call task.resume. Don't forget. I forget all the time. Now, once again, here we have a concrete type. You're probably going to have more than one request in your app, right? So I think you can see where we're going with this. We need to make this a little more generic. For our request, we already have a protocol to define that, so we can go ahead and switch that over to Requestable. Now the name doesn't really make sense, right? Because the request is just a protocol. So we can change it to resource. And now like this decode closure, we want to be able to control its type, right? We don't always, obviously we don't always want to return an array of people. So, so we can make resource generic over a type T, and then the decode block will just decode data and return something of type T. Great, now we can update our scaffolding. Essentially, this is kind of what we had before, where the signature of this method was this here for our concrete type. And we just move it over. We make it generic and make it over our generic resource. The actual implementation doesn't change at all. And just like that, we're good to go. Everything we wrote before still works. But again, we can make this spark joy. This, to me, still seems a little big. I think we can make it a bit better. This is pretty much the most common case, right? Like, we're receiving data and we're decoding it into a model object. So since this is the most common case, I feel like this should be a little bit easier to do, or else we would be copying this again and again. So we can create an extension on resource, use my favorite feature, which is like generic constraints. And when T is decodable, we have a new initializer where we only pass in a request, or a requestable, and we call into the other initializer to kind of set up this, this decoding block for us. And now, if we come back to view did load, it looks something like this. So this is like a far cry of where we were before, right? Like, now requests and resources are only on one line. This is getting better. This is getting better. Another thing that can help spark joy is extending JSON decoder. One of the things I've found a lot of success with is being able to decode at a certain key path, kind of like we used to do in Objective-C, where you would receive JSON, but you don't need to decode like the whole JSON, right? You only need like a certain part of it. If you can like isolate that key, pass it to JSON decoder, then you can make your life a whole lot easier and not deal with data that you don't need. I didn't put the implementation of it here because honestly, it's like code that's not safe for work, quite literally. I feel like if we were to upload this to YouTube, the CocoaHeads account would get like banned. But if you want to see it, I can show you after. Just come see me. All right, moving on. Environments. Right now, there are a few limits, right, to our current solution. We're locked into a single URL per request. Now, this is a problem. I assume most of you are working in environments where you don't have like one backend, but you have many, right? You have QA, you have staging, you have production, and you need to be able to easily switch between all of them. There's also the potential for a lot of repetition between requests. it'd be nice to have a way to say, to define something like, oh, these headers go on all of our requests, for example. And also, our view controller right now, because it's a massive view controller, is kind of locked into URL session, right? There's no way for us to pass in a different session configuration, and there's no way for us to even abstract out the whole like networking part. So let's have a look at that. Again, we'll start with a struct. We're going to add a base URL. We'll create a struct called environment and have base URL as a URL. Now we're going to update Requestable. So we're going to take our protocol, and instead of having a URL here, let's say we're going to switch that with a path. And now we're going to update our full, the concept of creating a full URL from our Requestable struct. This now becomes a function. So it's no longer a property that can only, that's like scoped to itself. Now we actually have a dependency, which is like the base URL of the of our environment. So we're going to have to pass that in. Again, here we're doing like simple URL component stuff, creating a URL, passing it back. So that's one part. Now let's look at additional headers. Often additional headers can take all kinds of forms, right? API keys. I know like AWS uses an XAPI key header that I've used that in the past. Custom accept headers. So for example, if you want to support like Shockwave Flash. I was looking for examples yesterday and I found this and I couldn't help but put it. I think this is amazing. I was like, wow, blast from the past. So if you want to like accept Shockwave Flash on all your requests, well, you would want like a single place where you can specify that, right? And then accept language too. This is big in Canada because a lot of apps have language toggles inside the app, so they don't actually respect the operating system. So you could have your operating system in English, but have your app, say, for example, in French. And when you're calling the backend, you would want the backend to return a response with like things localized in French. You wouldn't want them in English. So this is very important for us. So again, we can add that into our environment struct, additional headers. But now, like, how do we apply this, right? Like, how do we apply this to our request? We're not going to add all of this logic into our view controller. I mean, we could, right? It's massive, right? Like, we could totally do that. But let's not. So now would be a good time to kind of introduce an abstraction layer between the two. In this case, we'll call it API client. It takes an environment and it takes a URL session. By default, you get URL session.shared. So if you don't care, you don't have to worry about it, and saves those as like local variables. And we're going to take, oh boy, that's small. We're going to take the scaffolding that we put on URL session, and we're going to raise it up to our API client. So instead of asking URL session for a data task and passing in the resource, we're going to do it at this level instead. This way we have access to not only everything on URL session, but also the additional headers that we want to put and our base URL. And now our view did load looks like this, right? This is looking pretty good. You can assume that API client gets like passed into an initializer into like your view controller, and now your view controller can just call into that with the request and resource that it wants, and then set the data on itself, and then you're on your merry way. But now we can make this spark joy even more. Of course, you can take your environment, create like these static functions to generate these environments for you, right? Like these probably are not going to change. And then using this, why not create some sort of QA screen inside your app where you can like switch between environments. Alex Grebeniak, Keen.blog, he has a good post about this, and And yeah, highly recommend. So where do we go from here? We've created requests. We've created responses. We have environments. We have all of the scaffolding that we need in order to make it work. And all of this stuff fits in a few screenfuls of code. Like it's less than like 100, 150 lines. We could go further, right? We could talk about authorization. We could talk about integrating logging, any specialized caching that you would want to do. We can talk about supporting downloads or even like paged resources. But that's not quite the point. The point is not to build a it's not for me to tell you how to build a networking stack. The point is more so to show you that doing this stuff isn't hard, and if you go at it slowly, it's possible to build this in small increments. So, some takeaways. So you don't need fancy libraries or frameworks for your networking stack, right? Like you can build this all out of simple structs and like simple functions and extensions on things that already exist. And you can build something that's very powerful and full-featured. This, I think, is an important point, is that don't reach for an abstraction when you can start with a concrete type. This is something that I'm constantly struggling with and have to learn, right? Sometimes we like to think 2-3 steps ahead. Oh, like we just know there's going to be a protocol here, or we know we're going to need like some generic class for this. But instead, if you start off with a concrete type, and then you create a second and a third, then you'll find much more organically how these things actually resemble themselves and how they fit together. And also, this is a great way to share the love. What we've done here is take take an API, boil it down to its own little requests, and now we can take this, we can package it up, we can like share it within the organization as like a Swift package, for example, and have this like artifact that we can like maintain and keep up to date. And doing so is actually quite rewarding, and it's a lot of fun. So with that being said, thank you very much. And I would love to hear your questions.
Yeah. Want to go there first? All right. See if I can hit the beamer.
Yeah. Watch out. Oh. That's wonderful.
Yeah, first of all, thank you for your presentation.
Absolutely.
I was wondering, like I noticed you had default implementations for your protocols. How far would you reckon to go, as in it's also hiding implementation details? What's your recommendation about it? How far would you abstract default implementations as to not being implicit what the implementation is?
This is a good question. I think, like any good developer answer, it depends. If you find what's nice about having these like default implementations is that, again, it makes the simple stuff very easy to do. If you find yourself often like overwriting your default implementations, that I think it's like a clear warning sign that your default implementation might not be that default, right? Ideally, you have this stuff covered by tests, so then when you come and you like remove a default, a bunch of stuff breaks, you update it everywhere, and then you're on your way and you're good to go. But again, I think that's a balance that you have to strike with your team, or if you're solo, it's something that you just you'll figure it out for yourself.
Thanks.
You had a question.
Hi. Again, thank you for a presentation. Really, I like the way you go through the thought process. But I was just wondering about the one part where you said some people have the tendency to like intertwine the request and the response because they're usually intertwined, and then you mentioned the 3 backlashes of doing so. But then you introduced a struct which had basically a decoding strategy anyway. So wouldn't you say that basically, even if you were to intertwine it and include a decoding strategy, you basically solve all the problems that you mentioned? Because you can, decode to void, and by decoding to void, you can just actually just straight up cache in that little block and do nothing else. It kind of seems like it would, by just having this decoding strategy, even if they were intertwined, all the problems you mentioned wouldn't really be issues, or maybe I'm missing something.
Okay, so perhaps I didn't express myself too well. Usually, what I tend to see is that it's not so much a decoding strategy that people tend to package inside of their requests, but more so just like the type of the data that they're trying to decode. And because you have so little information, a lot of people, I feel like they take for granted that it's going to go through like a JSON decoder, and end up there. So that's kind of how I was approaching it. But I agree that if you wanted to, you could absolutely take the decode closure, put it on request, and yeah, maybe it might not be so great for things like downloading, because if you create a download request, you only need the raw data. You're not going to have any output whatsoever, right? So maybe in that case, it might not be the best abstraction. But man, if it works for you, like that's what's important with this. Like it's got to like sparking joy. That comes from the inside. It comes from the heart. If it sparks joy, then like I'm good with it.
Very true. Thank you.
Any other? Yep.
Thank you, Frank. You mentioned that you're doing consulting work, right? So I'm curious, like in your experience with different clients, like how often, like what's kind of the split between companies using their own develop their own networking stack versus using some libraries and to handle the networking part?
I feel like the answer to this would have been very different, even just 2 or 3 years ago. I find as we go on, at least what I've seen in Canada, is that more and more people are building out their own network, just their own stacks in general, not even just for networking, but for, say, data persistence, etc. Just to build small, focused tools for their needs instead of using frameworks that have a lot of extra baggage. Then again, I mean, I work for financial institutions, so they're kind of they're a little allergic to putting lots of libraries in their code that they don't necessarily manage themselves. And their pockets are deep, so they can take the time to build these things.
All right. Anyone else have a question? And I'd like to say thank you, Frank, for your presentation.
Absolutely.